So we will calculate, today we will calculate the static indeterminacy of the structure, and we know that it can be of two types. Number one, it is external indeterminacy, external static indeterminacy, and it is represented by ds total, and it is dse. Second one, internal static indeterminacy, and it is denoted by dsi, and therefore total ds, it is total static indeterminacy, and that will equal to be dse plus dsi. Okay. Concept of external and internal, it comes from the stability of the structure. It comes from the stability of the structure. In last class we have calculated the degree of freedom of all joints present in a structure, and we know very well that degree of freedom at joint is permitted only and only when rigidity of the structure is not going to change. Say for an example, if I have this frame, and these joints are supposed to be rigid. Suppose this joint number 1, it's 2, it's 3, it's 4. 4 number of joints are noted in this structure has. If we apply this type of force, horizontal force, then that structure may shift, deviate. That structure may deviate in this manner. Therefore, joint number 3 and 4 will have the motions, will have the degree of freedom, will have the movement. Joint number 3 and 4, they have the movement. Okay, what are those movements that we have calculated in our last class in determinacy, in kinematic indeterminacy. Okay, and here we are seeing that this angle and this angle, it is 90 degree, So before applying the load and after application of the load, since both are same here and here also 90 degree and 90 degree, since it is same, that's why that degree of freedom, that motion of the structure will be permitted. Okay, that degree of freedom will be permitted. So this much movements of this much horizontal movement and that much vertical displacement, that is permitted, as well as rotation will also take place. But if joint number 3 and 4, they are pin type of joint, means here it is not joint number 3, it is not rigid, pin type of joint. Then with application of this load, that structure may have this shape. That structure may have this shape, and this angle may have different value. Prior to load it was 90, but after application of load it is not 90 degree. It is not 90 degree, more than 90 degree. Yes?
नीचे तो फिक्स लगा हुआ है सर, तो नीचे
Yes. Okay. Let me correct over here. This one. It may it may have here rotation will not take place, but here any type of thing can be possible. Okay, agreed? Here that type of thing can be possible. So at this time it is the case when joint number 3 and 4 are pinned. Here joint 3 and 4 was fixed. This type of movement of frame, this type of movement of structure will cause the change in geometry of the structure. Will cause the change of geometry in the structure. Geometry means what? Prior to that and after application of load. If it is changing, then it is that structure is said to have change in geometry. That structure has change in geometry of structure. Change in geometry due to external load. That's why that degree of freedom will not be acceptable. That degree of freedom will not be acceptable. Clear to everybody? And that's why that structure is said to be unstable. That structure is said to be unstable. That structure is said to be unstable. And which type of instability it has? That should be clear to all of you. Which type of instability of this structure has? Is it going to move? As a whole in any one direction? Is it able to move as a single unit in any one of the direction, either horizontal or vertical or rotational? Is it not? That's why it is externally stable. It is externally stable, but it is not internally stable. Why? Change in geometry is taking place. Therefore, it is of course externally stable, but it is internally unstable. And finally we will say that it is unstable. Unstable may be in terms of both. It may be externally unstable, it may be internally unstable, but if any one of them is there, then we will say that it is unstable. Get to everybody? A structure will said to be unstable if any one of them, okay, is unstable. If any one of them. Clear to everybody? In that example, In that example, it is externally stable. That concept is clear to everybody? Very much clear to everybody? Okay? Why it is externally stable? Why it is externally stable? Then what will be your answer? It is externally stable because it has 6 number of restraint acting here. 6 number of restraint acting here. What are 6 number of restraints? You know very well. These are vertical restraint, horizontal restraint, as well as moment. Okay? And here also. Okay? Means total number of restraints, and they are equal to the number of supports, means 3 plus 3, that is 6. Okay, and all of them are not parallel with each other. And they are also not concurrent with each other. That's why they are stable. Okay, and we know very well that minimum number of required restraints, it is what? 3. And from where it comes? If I am taking entire structure as a point, means this entire consists of 2 vertical member, 1 this and support. If I am considering this entire structure as a single point, and if I am not interested to give any type of motion, then that type of motion should not be. If it is not expected, what it means? Total number of forces acting along that, it should be 0. When it will possible? When that point will be in static condition? When linear movement, horizontal movement is 0, and it will 0 when total number of force acting along horizontal direction, means value of sigma fx is 0. Clear to everybody? That is the condition. That is one condition. When this vertical movement is 0, when the vertical motion will be 0, it will 0 when summation of all forces along vertical direction is 0. It will possible only and only when summation of all forces along vertical direction is 0, means I need to write sigma fy equals to 0. Clear to everybody? Similarly, when that rotation will be 0, when summation of moment along z axis, it is 0. Along z axis is 0. I am taking here axis as this one is x, this one is x, this one is y, and z is this, perpendicular to that. Clear to everybody? So sigma fx, sigma fy, sigma mz, these are total number of required restraints, or you can say minimum number of equations available to us. In analysis, these restraints are treated as equilibrium equations. These fx, fy, sigma mz, they are treated as equilibrium conditions. They are also treated as equilibrium conditions. And in that condition, since entire structure has to be taken as a point, that's why these conditions are called as global conditions. Globally, all this type of condition must be satisfied. Globally, that condition must be satisfied if we want to make stable structure in terms of externally. in terms of externally. That condition must be satisfied. That condition must be satisfied means sigma fx 0, sigma phi 0, sigma fx, sigma phi and sigma mz 0. That condition must be satisfied to have externally stable. To have externally stable. And one more condition which you need to check is very simple. All resistant forces should not be parallel with each other and they should not be concurrent with each other. That is regarding external stability. That is regarding external stability. Clear? In that example, total number of resistants are same, so it is also applicable here. So it is that structure will also said to be have externally stable. Externally stable. Okay. Since joint 3 and 4 are rigid, that's why it will also be have internally stable. It is stable internally as well as internally, but it is not. Okay, it is not. What we have to do? What we should do to make that stable condition? What we can do for this structure to make internally stable? What we can do? Yes, we can make this. We have the options to make this change of geometry by providing this change of geometry can be restrained. This change of geometry can be restrained by means of provision of more number of members. By providing more number of members. Here, since at two joints, geometry are going to change. That's why we need to add two members. Because one member, if it is joint number 3 and 4 are, if now joint number 3 and 4 are pinned, then which type of structure it will called? It will called as truss type of structure. It will called truss type of structure. It is frame type of structure. And we know very well that if a truss member has only either this one type of force or this one type of force. In truss, individual member can carry only either compression or tension type of force, and at two places geometry is going to change, therefore we have to provide two more members like this. If I provide this type of thing, if I provide this type of thing, okay, I think by providing only this, if I provide this type of thing, if I provide this type of thing, means that additional, this one and this one, they are the additional member. After having this two member, it will be internally it will have internally stable also. Which one? इसको अगर हम हटा भी दें, it will just wait. It will have internally stable. It will have internally stable. Look here also. One more thing I want to explain here. If support acting at joint number 1 and 2, ध्यान से समझे what I want to explain. At node number 1 and 2, at node 1 and 2, they have fixed type of thing, fixed type of supports. Okay. Therefore, provision of this member, if I reduce this member, if I reduce that member, then there will be no any effect in instability. होगा क्या? It will not be. Why? Because they are fixed. Because they are fixed. Because it is fixed. So it has one conclusion. It has one conclusion, and that conclusion should be very much clear to all of you. What is that conclusion? इसको कैसे समझना चाहिए? The conclusion is, if we are providing here number of restraints required, how many? Required restraints for externally stable position, it is only 3. And how many restraints we are providing? 6. Means we are providing 3 more restraints. If we are providing more restraint, then number of member can be reduced. Can be possible to reduce. It is not always true that if we reduce the number of member and we increase the number of restraints at the support, then the structure will become stable. It may possible. I will give you one more example. If I have this type of thing, this one example of if I am providing this type of arrangement, then okay, this type of arrangement, it is externally stable or unstable? It is externally stable. But if I am providing this type of thing, if I am providing okay, how many number of restraints here I have applied? 2 and 3. Number of restraints, 3 number of restraints I have applied here. So minimum number of restraints required, it is 3, and applied it is same. So it is externally stable. But internally unstable. How we can make that structure stable? By providing one more member here, okay, and another one. Both members were missing. Since they are missing here, this one missing, that can be, that this is optional. You may provide, you may not be provide. Okay, but if in place of roller support, if situation is like this, in place of fixed, if it is hinge, in place of fixed, if it is roller, then we must have 2 additional members. then it will be externally stable. Clear to everybody? Clear to everybody? In that case, minimum number of restraint, it is exactly same. Minimum number of restraint, 1 here, 2 here, it is exactly same. If it is exactly same, then minimum number of required member forces, that should also be, है ना, जितना भी minimum है, that should be fulfilled here. वो भी minimum required is that. Okay, minimum required is that. So finally, what is the meaning of external static indeterminacy and internal static indeterminacy? I have its physical significance. I have told you. In structural analysis, if we are providing more number of restraints, अभी ध्यान दें, if I am providing, if for external stability, what is the meaning of stability? Stability does not has any magnitude. It can be increased slightly. Okay, if here in this, how many number of restraints we have applied? 3. If we have, okay, here, if I am applying thin support here also, then how many number of restraints I have applied here? 4. Number of restraints I have applied 4. Here 3, here 4. 3 number of restraints, here 4 number of restraints. What I am doing? I am making more stability. I am going to make that truss, this one, truss more stable. I am externally more stable. This structure is said to be externally more stable as compared to this one. This one, okay, this one is much more stable as compared to this one and this one both. Why? Because it has total number of restraint, how much? 6. Total number of restraint, 6. Clear to everybody? What I want to tell you? It is more stable. How much it is more stable? It is why it is more stable? It is stable because 3 number of restraints we have added more. Okay, we have added 3 more number of restraints. This is externally stable because we have added 1 more. It is just stable. It is just stable. That I want to tell you. It is just stable. Okay, if we remove any one of the, if I will remove any one of restraints like this, roller, if I remove any one of them, here only 2 restraints are acting. What I did here? I removed this one horizontal restraint I have removed here. And when that restraint is removed, okay, then what will happen? It will be unstable. Why? Because if horizontal force is acting, then it will going to move. Number of restraint it is here. Number of restraint here is 2, and it becomes now it becomes unstable because the minimum number of restraint requirement, because it fails in minimum number of required strength. Clear? It is just stable. It is just stable. It is unstable. It is just stable. It is more stable. It is much stable. Okay. So static indeterminacy, external indeterminacy, it is the number of. It can be written as extra number of restraints required. Extra number of restraints applied. Extra number of restraints applied apart from minimum requirement. Apart from minimum requirement. And what is the minimum requirement? What is minimum requirement? Minimum requirement for plane. For plane, it is small r is equal to 3. For space, it is 6. It is 6. Clear to everybody? So this is the concept of externally external indeterminacy. External static indeterminacy. This is the concept. This is the concept. Okay. And internally stable, I have told you minimum number, and now I will discuss one by one, because we in a structural analysis we can have the structure like truss, we can have the structure as beam and frames. Generally we are dealing with 3 type of structure. Now I will formalize the expressions for both external as well as internal indeterminacy in case of truss, in case of beam, in case of frame. Okay, the physical significance I have given you till date. Okay, अभी तक मैंने क्या दिया है? केवल only physical significance. I have not given you any expression how to calculate the value of external indeterminacy and this. Now I am going to give you the different expression, different formula to calculate the value of external and internal static indeterminacy for that type, either truss, beam or frame individually. Yes. Any question? End out? This, if it is plain.
How much member may have to use in that, sir?
How much member? Okay, that I will discuss. That I will discuss when it will discuss separately. It will discuss separately. In case of truss it is different. In case of beam it is different. In case of frame it is different. When it will be discussed separately. Okay. Clear to everybody? Acha, one more thing before going to start static indeterminacy for truss. One more thing I would like to tell you. I have written here extra number of restraints. Extra number of restraints applied apart from minimum number of requirement, and this terminology in structural analysis language, it is called as redundancy. It is called as redundancy. In structural analysis, that extra number of restraints applied in a structure apart from minimum requirement, they are called as redundancy. Okay, this is the physical significance of, physical meaning of, physical definition of redundancy. Therefore, you can say that what is static indeterminacy? It is the summation of redundant externally as well as internally. Okay, it is a summation of redundancy. Redundancy, the term which we are using summation of redundancy, externally as well as internally. Okay, extra number of member applied, that is called as extra number of members applied, that will be that they will be referred as redundant, internal redundant. They will referred as internal redundant. Okay, here if I am providing, look here, if I am providing that member, one more member, then that member will be extra member. That will be extra member, and that extra member will be called as internal redundant. That everybody? So if I am calculating the indeterminacy, static indeterminacy, then what will be our answer? External indeterminacy, it is 1. Look here, for that case, what will be the value of DSE and what is the value of DSI? It is 4 minus 3 equals to 1. Clear to everybody? 4 are applied, 3 is required, 1, okay, and DSI minimum, it is extra member is 1, okay. Extra member अभी बताऊंगा मैं, okay, it will be communicated to you. What is the minimum number extra member? I will tell you. Okay. I will tell you that ये extra member कितना required है, कितना क्या है, that I will tell you. Okay, separately for case of trust, for case of beef, for case of. So now I am going to explain static indeterminacy for trust. For trust. Trust, this is the, in this here it is a smallest trust. It has how many joints? 1, 2, 3. 3 number of joints, 3 number of member 1, 2, 3, 3 number of member, and restraints here we have applied 2 restraints here, 1 vertical, 1 horizontal, here 1 vertical, number of restraint applied here 3. It will be called as truss type of structure if it has, if its all joints are pin type of joint. And one more thing, no any load will act away from joints, means all type of load will act through joints only, means this is, since this is smallest, this is bigger, load can be applied through that joint only. Load can be applied through that joint only. It is not possible to apply a load here. It is not possible to apply load here. Load can be applied from the joint only. We cannot apply any type of load like this. Okay, this is not permitted. Okay, we cannot apply any type of UDL load like this. It is not permitted. It is not permitted. If this type of thing is that, then it is called as stress. You know very well. You know very well. Okay. Now I am going to calculate static indeterminacy. Okay. I am going to calculate the both indeterminacy externally and internally. Okay. So how it will be calculated? It's very simple. First of all, I would like to tell. Consider this example. Consider this example. Number of joints here. Number of joints here. 1, 2, 3, 4, 5. Number of joints are 5. Number of member number 1. Member 1 here. 2 here. 3, 4, 5. 6, 7. Okay. These are nodes. How many members? 7 members. Number of restraints. I am capital R. Capital R means number of restraints applied. How many? 1, 2, 1, 2. It is 2 plus 2 equals to 4. Capital R is what? Number of restraints, means number of support reaction. Number of restraints means number of support reaction. Clear to everybody? This is that one. Okay. Now, and minimum, I am introducing a symbol small r. If I am saying for small r, if small r is the minimum number of restraints required if capital R is the minimum number of restraints required, R is the applied, capital R is the applied restraints. Okay, then what will be its external indeterminacy? Can you tell me? Its external indeterminacy, external static indeterminacy, it will be how much? Capital R minus small r, and it will be DSE. This is the general expression. This is the general expression. Capital R minus small r, and you know very well what is the value of small r. It is 3, it is 6, 3 for which one? 3 for plane, okay, and 6 for space. You know very well. It's very simple. Now for external, this is for external. Now internal static indeterminacy. Now for internal static indeterminacy. To calculate the internal indeterminacy of this stress, we have to consider every joint. We have to consider the stability of every joint. Look here. How number 3, number 6 has been formulated? How this number 3 number for a plane, 6 number for a space has been formulated? Considering this entire truss as a single point. This entire truss as a single point. Okay, but it is not a single point. It has 5 number of joint, it has 7 number of members, and it may also have different type of load. It may have different type of load. Okay, if our scale of vision is much broad, then it can be treated as a point, but it is not as a point. Okay, if we are treating its individual joints stability, केवल हमें बाहर से नहीं मतलब है, हमें अंदर के joints को भी stable देखना है. We want to make stable of every joint geometry. We want to give the stability of joint also. Within that structure we want to give the stability. Which means I want to give the stability at joint number 4, 5, 2 also. Okay, I want to give the inside stability. Therefore every joint has to be considered. Therefore every joint has to be considered. Every joint has to be considered. Clear to everybody? How many joints? It has 5 number of joints, and we know very well degree of freedom per joint in case of truss. Kitna? How much? Degree of freedom per joint. It is 2 in case of plane. In case of plane truss, 1 horizontal and vertical, and it is 3 for space. Delta x, delta y, and delta z. Degree of freedom per joint. Degree of freedom per joint. That I have told you, na? It is clear to everybody, na? In space, in plane, since a member can have either this type of force or this type of force. It is compression, it is tensile. Therefore, any joint can have only two possibilities. Either joint number 1 can move in horizontal direction or vertical direction. That everybody. Their joint 5 can move in horizontal and vertical direction. Degree of freedom per joint. Clear? And if we want to make, if we do not want to have any degree of freedom, if we do not provide any movement at the joint, what will be the condition to make internally stable? When degree of freedom of all joint has to be stopped. That everybody what I am going to tell. Externally stable, it's very simple. Consider this as a single point. Okay, inside all joints, since it has total number of 5 joints, and every joint has 10 degree of every joint has 2 degree of freedom. And if I am expecting internally stable, then all degree of freedom at the joint must be 0. Must be 0. That structure will not have any degree of freedom if all joint is not able to move in any direction. Clear to everybody? Therefore, how many number of possibility for movement? How many number of joint multiplied by degree of freedom? Degree of freedom. Okay, that will give you the required number of conditions which you have to restrain. Therefore, you can write total restraints needed to make stable, to make all joints as stationary, as static. How many restraints needed to make all joint as static? कितना होगा? How much? It will be number of joint multiplied by degree of freedom. Multiplied by degree of freedom per joint. Okay? It will be 2J, it will be 3J. It can be 2J, it can be 3J. Got everybody? Total number of restraints needed. Clear? Next, number of restraints. Number of restraints applied. Number of restraints. Now number of restraints applied. First one is for external and second one is for internal stability. Number of restraints applied for external stability and for internal stability. Number of restraints applied for external stability. How much? Capital R? What I should write here? Capital R. And for internal stability, what I should write? Should I write M multiplied by, should I write here M only? Should I write here M? Why I am writing here M? Because I am writing here only M. It is because one member can carry only one type of force only. So if it has seven member, then seven number of force it can carry. Means it is able to provide 7 number of restraints. It is able to provide 7 number of restraints. If the member, for an example, if the member is able to carry more than one, means if the member is carry 3 type of forces, if member is able to carry 3 type of forces, then total number of restraints applied by one member kitna hoga? 3. Okay. So therefore, if total number of members are M, then in that case it will be 3M. It will be 3M. 3M will be for beam or frame type of structure. For frame type, in frame, one member can carry 3 type of force. I will discuss you later on. But here, since one member can carry only one type of force, therefore total number of restraint, okay, applied to give internal stability, it is only M. Clear to everybody? It is total. Therefore, total static indeterminacy. Total static indeterminacy, DS. Can you write it? Kitna hoga? How much it will? It will be total restraints. It will be total restraints applied minus total restraints applied minus restraints, total restraints needed. Required, applied kitna hai? How much is applied? How much is needed? We can formalize now. Total number of restraints. How much total number of restraints applied? It is capital R plus M. It is capital R plus M. Okay. Summation of this number of restraints applied. Individual for R, capital R for externally, internally. It is capital R plus M. Okay. And needed kitna? Minus kitna? Total number of restraints needed. How much? In case of plane, this is plane type, means it will be 2Z. So it is the expression for. It is the expression for किसके लिए? Plane type of stress. It is for plane. It is for 2-dimensional, means plane type of stress. Plane stress. It is for plane stress. And what will be the expression for space stress? Capital R plus small m minus 2Z. It is for 3Z, right? 3Z for space stress. Okay, this is total static. This is the expression for total. Okay, and we know very well what is the value of external indeterminacy DSE. We have derived the expression capital R minus small r. Therefore, internal DSI internal can be calculated, है ना? DS minus, very simple. Okay. Internal can be calculated by total minus external. So write it. capital R plus small m minus 2j minus it is for minus capital R minus small r. Okay, something well, this will be cancelled out. So finally we will have small m plus r, है ना, या स्मॉल m प्लस r माइनस 2j. ये दिस इज द एक्सप्रेशन फॉर DSI. Okay, for plane, and similarly m plus r minus 3j, it will be for okay. So we have two expressions. This is for total, this is for total. Total में क्या है, कैपिटल R प्लस m, या आप ऐसे करो इसको, यू राइट हियर m प्लस स्मॉल m प्लस r, थोड़ा सा बोलने में अच्छा लगता है, स्मॉल m प्लस कैपिटल R माइनस 2j. व्हाट इज द डिफरेंस हियर, m तो है ही है, m प्लस स्मॉल r. Okay, small r will be used if we want to calculate the internal. For total, it is total. That everybody. Now at this level, after knowing that expression, we can calculate the value. We can calculate the value of what will be the values for that case. For that case, what will be value? Okay, for solution here DSE, external indeterminacy, capital R minus small r means 4 minus 3 equals to 1. DSE DS total DS निकाल लें, या DSI it is small m plus small r, small m 7 plus 3, small r value is here 3, minus 2j is 2 into 7, no, 2 into 5, so it is 10 minus 10 comes to be 0. So the value of DSI is 0, and total is 1 plus 0 equals to 1. Clear to everybody? Total is that. If anybody has any problem, any doubt, he can ask. Any problem? Any doubt? Okay, very good. So this is the conventional procedure. This is the conventional procedure to answer for static indeterminacy of distress. आपको ऐसे ही करना है. What you have to do? You have to count the number of joints, you have to count the number of member, you have to find the total number of resistance applied, means total number of support reaction, value of small r, it is known to you, 3 and 6, depends upon the either space or wo. DSE, capital R minus small r, simply find that value, DSE, small m plus small r minus 2j, find out total is that. Clear to everybody? Now I will come. So for trust, what we have the expression which you have to remember, you have to remember capital E, yes, you have to remember DSE equals to capital R minus small r, and DSI you have to remember small m plus r minus 2j for plane type. Okay, I am writing here only for plane, and total ds equals to m plus capital R minus 2j. That you have to remember. This is for plane. for plain truss. That you have to remember. Now I am going to tell you what are the minimum number of members to be required. What are the minimum number? Now what I am going to tell you, minimum number of members required for internal stability. That I want to explain. That I want to explain. That I want to explain. Look here. If the value of ds equals to 0, if the value of ds equals to 0, if the value of dsi equals to 0, what is the meaning? What is the meaning of ds equals to 0? What is the meaning of dsi equals to 0? Structure is just stable. Okay na? It is limiting condition. Structure is just stable. If we will remove any one of the restraints, any one of the support restraints, then it will become unstable. Similarly here, if we will remove any one of the member, then it will be unstable. Oh, this is the minimum requirement. Okay, minimum requirement कैसे निकलेगा? Equate it as 0. Okay, if you want to calculate the minimum number of restraints required, equate it as 0. ds value as 0. Then what will be that? Capital R will be what? Small r. Capital R will be small r. Mathematically it can be formulated. And that thing I have told you in other way. Consider entire structure as a point. Okay, so this one thing. Similarly for that, equate it as 0. Okay, these are the conditions for, इसको लिखना है ना, these are the conditions for, क्या लिखा जाए? Just, these are the conditions to have structure just stable conditions. Just stable condition. Got everybody? Okay. Therefore, number of restraints. Therefore, ये भी लिख सकते हैं. Therefore, minimum restraints needed. नहीं ऐसा लिखो. Therefore, if ds equals to 0 means capital R minus small r equals to 0, then value of r minus r equals to r. Okay, and value of r you know very well. Capital R is equal to 3, small r equals to 3, and it is 6 for plane, for space. Okay, and capital R क्या था? Applied. Capital R was the applied restraint. Okay, this is for उसके लिए. Now for come to here for stability. So equate this one as 0. DSI, since we know that value, DSI, equate that value as 0. Capital M, and small m plus r minus 2j equals to 0. So the value of m, it comes to be 2j minus r. So this m, it will be what? Minimum number of members. At that time, it will be the minimum number of members. It is the minimum number of members. M is equal to 2j minus r. It is the minimum number of members. Clear to everybody? It is the minimum number of members. For example, if value of j equals to minimum कितना हो सकता है j 3 ना, इससे कम तो नहीं. If j equals to ऐसे लिखे, if ये टेबल बनाए, मेगा टेबल m मिनिमम का, मिनिमम m. If the value of j is 3, then it is number of member. इसको ऐसा लिखने क्या, 2j minus 3, we can write it 2j minus 3 for plain, 2j minus 3 we can write it. So what will be that? 3. If it is 4, number of joints are 4, how much? 5. If it is 5, then how much? 7. If it is 6, how much? 9. If it is 7, 11. Okay. If it is 8, and so on, and so on. Got everybody? So in that expression, in that structure, number of members are 7. It means exactly same. It is exactly same for internal stability. That's why it was 0. That's why it was 0. Clear to everybody? If no, it's not possible. Clear? Suppose I have another type of truss. Suppose I have this type of truss. Suppose I have this type of truss. Okay. Tell me number of joints. Number of joints. 1, 2, 3, 4, 5, 6, 7, 8. Number of members. Number of members. Count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So इसमें चेक करें. What is the minimum number of members required for 8 number of joints? 13. 8 के लिए 13. हाँ. And here we have applied 11. That's why that truss will not be internally stable. That if we will calculate the value of DSE, if we will calculate the value of DSI, then it will be small m plus r minus 2j and expression m11 plus 3 minus 2 means 8. So 14 minus 16. So it will be minus 2. It will be minus 2. If it is minus 2, then unstable. And one more thing, two members are required. Minus 2 means 2 number of members are required in case of truss. And here that table also explains that for 8 number of joint you need 13. Okay, so 2 number of members you can have this type of arrangement. If you provide 2 members one here, another here, then it will be stable. Okay, come here. If I have, यहाँ पे ध्यान से समझे जो कहना चाह रहा हूँ. If I have three joints, then three members required. Okay. If I have further one joint, then number of members required, additional number of member required, only two. Okay. Additional कितना है ये? टू ही तो है, हर एक में टू ही जा रहा है. So two members, this one. If I have one more joint like this, two members more. If I have further one joint, then I need one. Further I have one, two members. It gives you some conclusion. And conclusion is what? That I want to tell you. It is very important conclusion. Conclusion है truss type of structure always has triangular geometry. It has triangular geometry for just internally stable condition. Okay. If the structure has to be externally stable, if the truss has to be if the truss has to be internally stable, then its geometry must be triangular. This type of arrangement cannot be possible. Here, this arrangement can never be possible. Okay, this is not triangular. This is triangle. This is triangle, but this is rectangular. Okay, so by single observation, okay, आप देखते ही पहचान सकते हैं. You can tell whether that truss is stable or not by simply seeing. By simply seeing, you can tell that structure is not stable. Okay, why? It does not have any triangular geometry. Externally, okay, two here, one here, externally okay. Internally, find out. Okay, if this one and that one is given, that is applied, then it is externally stable, and value of DSI equals to 0. If this type of thing is that one more, that will be treated as extra member. Clear to everybody? That extra member is for what? Apart from the triangular geometry. That member is apart from the triangular geometry. If I have applied this also, that member will also be extra member. Clear to everybody what I want to tell you? If I have applied here also, then that will also be extra member. So in that procedure, I have applied how many extra members? 3. One extra member. 3 extra members I have applied here. By simple observation you can notice. And these 3 extra number of member will give you the internal indeterminacy. These 3 extra member will give you the value of internal indeterminacy. It will be 3. You can verify through the formula also. In case of formula, you have to count the number of joint, you have to count the number of member. Put that, you will get the same value. same. Clear to everybody? How verify how many number of forces is there? It is 3. It is 14 here. Nahi. How much? How many number of members? You tell me. Number of members here. Joints are 8. No problem. Kitna? 17. 16. Okay. Put the value of here 16. How much you will get? 16 plus 3. 19 minus 16. You will get this. So it is. This conclusion is very much helpful. This conclusion is very much helpful to find the value of internal. Okay, internal indeterminacy. Internal indeterminacy. Clear to everybody? Internal. कैसे करेंगे? Find out the extra number of members apart from the geometry. Apart from the geometry. Clear to everybody? If I am giving you this type of truss, if I am giving you this type of truss, okay, this type of truss, can you tell me its indeterminacy? Value of DSE, value of DSI, can you tell? ये क्वेश्चन है. Find total DS, DSE, DSI. टोटल क्या है ये? कैपिटल आर माइनस स्मॉल आर. व्हाट इज द वैल्यू ऑफ कैपिटल आर हियर? 4 minus 3. 4 minus 3, it is 1. No problem. It is very simple. Okay. Value of DSI. We have two options. Calculate the value of number of joint, number of member. Use that expression and calculate the value. Okay. You have one more option. Find the extra number of member. How many extra number of member apart from the triangular geometry? 2 member. Anyone that can be, that is extra member, that can be treated as a extra member. Okay, that can also be treated as a extra member. So value of 2. Get it everybody? And total value 0 plus 2 9. 1 plus 2 equals to. Clear to everybody? Clear to everybody? You can verify also. Verify भी कर सकते हो. Verify करो. Verify through formula. Number of joint. 1 2. अच्छा, this one will not treated be as joint. Okay? Overlap. This one will not be treated as joint. So number of joint here 1 2 3 4 5 6. Okay. Number of members. How many number of members? Count. 13. 1 2 3 4 5 नहीं. कितना हुआ? 4 5 6 7 8 9 10 11 12 और ये 13. Okay. Number of member 13. Okay. Value of capital R. It is 4. Small r. Put the formula. DSE. DSI. Small m plus small r minus 2j. Small m 13 plus 3 minus 2j. 2 into 7. So it is 16 minus. It is same. It is the same. ओके यस
सर उसको जॉइंट क्यों नहीं कंसीडर करते?
ज्वाइंट पिन ज्वाइंट नहीं है ना, अरेंजमेंट नहीं किया गया. अगर इफ दिस टाइप ऑफ थिंग इज देयर, ऐसे अगर बना है, देन टेक इट एज ज्वाइंट. ओके, देन टेक इट एज ज्वाइंट. इफ सिंपली इट इज लाइक दिस, नहीं अलग होगा. इफ इट इज ज्वाइंट देन आंसर विल बी डिफरेंट. If it is joined, then if both are joined, then the value of DSI will be 0 because triangular geometry will be there. Clear? Triangular geometry will be there. Value of DSI will be 0. Okay? They are simply like this. ऐसे. नहीं, DSI. हाँ, मेंबर बढ़ेंगे. टू ज्वाइंट 9 हो गए. मेंबर कितने बढ़ गए? हाँ, तो ना, इसमें तो कोई कंफ्यूजन वाली बात नहीं. अगर इस तरीके से है और ज्वाइंट मेंशन नहीं है, इफ द ज्वाइंट इज नॉट मेंशन देन टेक इट एज ज्वाइंट नहीं लेना है. ओके यस, वन क्वेश्चन. देयर इज वन डाउट. दिस वाज द सिचुएशन. There is one doubt. If I am taking this as extra member, then what is difference? We have to count only number of extra member. इसको मैं लूं या इसको लूं, कोई फर्क पड़ता है क्या? हमें तो वैल्यू बतानी है DSI की. क्लियर ना? किसी को भी ले लो, चाहे इसको लो चाहे इसको लो. मतलब है क्या, कुछ डिजाइन करने जा रहे हैं क्या हम, है ना? We do not bother which one is extra, but we have to know the number of extra member. You can take this, you can take this. Okay, you can take it. Remove that member and notice, is it triangular type of geometry or not? Okay, any doubt? So this is for today. Okay, thank you. For the calculation of static indeterminacy for frame and beam, this is the example of frame, this is the example of beam. Okay, these joints, if it is joint number 1, 2, 3, 4, then 4 and 3, they are rigid joint. They are rigid joint. Okay, here 1, 2, 3. 3 number of joints are here. 1, 2, 3 number of joints are here. Okay, so if J equals to number of joints, M equals to number of members, M equals to number of members, and capital R, number of restraints means support reactions, number of external restraints means that is support reaction, support reactions. If small r is number of, what is that? Number of yeah, number of equilibrium conditions. 3 in case of plane and 6 in case of space. Taking a for plane type of structure. For plane type of structure. External indeterminacy, external static DSE, it will be capital R minus small r minor okay. And internal static indeterminacy means DSI. How it will be calculated? Internal static indeterminacy. To calculate, to find the internal static indeterminacy, we must have total number of, what is this? R. R is the number of external extents applied, and small r is number of equilibrium conditions, means required restraints for equilibrium. Here, since we are considering the static condition, internal static condition means every joint has to be in static position. Every joint has to be in static position, and we know very well that degree of freedom of every joint is how much? In case of beam and frame, it is 3. Degree of freedom per joint, it is 3. This. Therefore, number of required restraints will be how much? Number of joints multiplied by 3. Okay, total degree of freedom, if number of joints are J, J is the number of joints, and we know very well that degree of freedom is 3. Okay, for plane type of structure. For total degree of freedom of all joints, it will be, yes, total अब ऐसे लिखें, total restraints applied at all joints is equals to total restraints applied at all joints for static condition. It is degree of freedom per joint number of J means 3J. Total number of restraints applied नहीं required. Total number of restraints required at all joints for static condition. 3 degree of freedom into this. Okay. We know very well that every member in between 4 and 3, every member, if we are cutting that section, then this joint and this joint, it has this type of force. Either it is this case or it is here. At any section, if we cut it, then we will find that for that one part, for this one part, we will find this type of for this one part and for this one part. Okay. When both are at the same point, when both are coinciding with each other, then effect of this is counterbalanced with that. Effect of this is counterbalanced with this. Similarly, movement, rotation, clockwise, anti-clockwise. Okay, counterbalance, it is 0. Why they are producing? They are producing because of load. Whenever load is applied, that type of force are produced. That type of force are produced. Kya do everybody? That type of force are going to produce. Clear? So every member has 3 type of forces. Every member has 3 type of forces. Every member has 3 type of forces. This one and this one constitutes shearing, bending, okay, axial. Okay, how many type of forces are there? Combination of this one and this one. This is shearing action. This is shearing action. This is bending action. This is bending action. This is axial action. Okay, because they are the same point. It can be here, it can be here. In both cases, every member has 3 type of forces. Every member has 3 type of forces. Okay, it means one member can resist 3 number of restraints. Direction, it depends upon type of the load. मुझे उससे नहीं मतलब है, आप चाहे इसको आप नीचे कर लो, उससे कोई लेना देना नहीं. आप इसको ऐसे कर लो, इसको ऐसे कर लो, नो प्रॉब्लम. शेयरिंग एक्शन, शेयरिंग फोर्स, ऐसा भी कर लो, ऐसा कर लो, मुझे उससे डायरेक्शन थोड़ी लेना है. ओके, क्या फर्क पड़ता है? रिजल्टेंट इज 0. मुझे इसकी वैल्यू कैलकुलेट नहीं करनी है. आई डू नॉट नीड टू कैलकुलेट द वैल्यू एग्जैक्टली. हाँ, these are the possibilities of the loads which can be acted over here. These are the possibilities of the loaded possibilities. Okay, maximum possibilities. Only 3 type of forces can be there. Three type of forces can be there. Yes. Possibilities. Only three possibilities. नहीं होगा. Maximum. These are the maximum three possibilities. These are the maximum three possibilities. Okay. Maximum three possibilities. If load are not acting, then anyone may be zero, any two may be zero, yeah, all of them will be zero. It may be the possibility, no problem. It may be the possibility. If anyone, any two, or all of them may be zero, it will depend upon the magnitude of the force. Clear to everybody? So, when three number of forces are acting, can act at a single member. What it's mean? One member is able to resist, able to provide three number of restraints. One member is able to provide three number of restraints. One member is able to provide three number of restraints. Listen what I am trying to tell you. Since here you write, since every member, since each member can resist three number of forces, and therefore one member, therefore total number of restraints provided by all members, how much? कितना होगा? 3 times of m. 3 times of m. Clear to everybody? Since each member can resist three number of forces, and therefore total number of restraints provided by all members, 3m. Okay? And externally, at the support, externally we have applied some restraints. Okay? How many restraints? Restraints are applied two ways. First one, due to member and due to this support. Capital R, number of external restraints. They are the, what is this? This is the internal restraints. This is the internal restraints. Capital R is the external restraints. So total restraints. Okay. Total restraint. Therefore, total restraints of structure. How much? Yes, 3m plus capital R. 3m plus capital R. Clear? Therefore, you can calculate the value of दोनों में. It is applicable for both. Therefore, you have calculated total restraints of structure and total restraints needed, total restraints required. है ना? Difference will be what? Total static indeterminacy. Difference will be total static indeterminacy. And how much it will be? Required is this, provided is this. कितना? 3j minus ये हाँ 3m plus r minus. So total static indeterminacy is total static indeterminacy means ds is 3m plus r minus clear to everybody? 3m plus r minus 3z. This is the total static indeterminacy. Okay. To calculate the static indeterminacy, we have only one expression. Of course, we have only one expression. And what is that? Total number of restraints minus required number of restraints. Total number of restraints minus required. Total is 3m plus r. 3m is internal restraints. Capital R is external restraints. Total restraint 3m plus r. Okay, required minus 3j. It is for plane. It is for plane. And what will be expression for space? Can you tell me?
3m plus r minus 6j.
Not 3m. 6m plus r.
Yes, sir. 6m.
Let everybody. Because why 6m? Every member will have 6. Every member can have 6 number of forces. That's why for space ये यहाँ पे लिख लेना ds for space it will be 6m plus r minus 6j. It is for space. That everybody? Okay. That should be very much clear to you, all of you. Remember, but with understanding. Okay? Any problem? So this is total. Now you can calculate the internal static indeterminacy. You can calculate the internal static indeterminacy. कैसे? It is external. This is total. And you know very well, summation of total is external plus internal. So subtract. Okay? Subtract. Best. Therefore, internal static indeterminacy DSE, DSI, total DS minus DSC. Okay, put that. मैं प्लेन का कर रहा हूं. Okay, I am doing for plane. 3m plus r minus 3j minus capital R minus small r. Capital R will be cancelled out, and finally we will have 3m plus minus plus minus 3j. DSI. It is for plane. Okay. For space, can you write? In place of 3, it will be 6 times. So for space, 6m plus r, small r minus 3z. Yes. You are right. Clear, beta? One more thing is remaining now. If what will happen? What will happen if it has member hinge? What will happen if it will have member hinge? What will happen if it has, or it has both type of, or if it has both type of internal hinge. If this joint is 1, if this is 1, this is 2, this is 3, 4, 5, 6, 7, 8. If at joint number 5, member hinge, joint hinge, and in between 7 and 8 member hinge. Okay. So what will be the changes? What will be the changes? Okay. So note करके लिखें. If member has, note करके लिखें, heading डालें. If structure has internal hinge, if structure has internal hinge, if structure has so for if structure has क्या लिखा? Internal hinge. Internal for internal hinge, and you know very well internal hinge can be provided, can be of two type. Either joint or member. क्या डेरिवेटिव? Okay. For example, at joint number 5, okay, क्या है ये? Joint internal hinge. ये this one member hinge. Okay, this is a member hinge. Its effect in calculating static indeterminacy is only in external indeterminacy. What are the role joint member and joint hinge internal hinge or member internal hinge? What is the role? The role is addition of degree of freedom. These are the additional degrees of freedom. If the internal hinge is there, member is there, then additional. How many additional degree of freedom will be there? 4. For this, n minus 1. Okay, m dash minus 1. M dash value is 1, 2, 3, 4. M dash value is 4. Here means 3 additional degree of freedom. Here 4 degree of freedom. Okay. If they are providing additional degree of freedom, it means our structure is going to move. Our structure is going to move. And its effect is to reduce the for internal hinge. Let m dash is the number of members meeting joint or member. Joint or member. Joint or member. For example, at joint 5, value of m dash is 4. At member hinge value of m dash is how much? 1 2. यहाँ पर number of members connecting to that hinge. How many? 2. m dash is 2. Okay. m double dash कर लो, no problem. डबल डैश कर लो, डबल डैश और सिंगल डैश जैसा भी, डू नॉट गेट कंफ्यूज. सो वैल्यू ऑफ या एडिशनल restraints needed, additional restraints needed, it will be 3 times of m dash minus 1. No, it is m dash minus 1 for plane and 3 times of m dash minus 1 for space. Additional restraints needed. Additional OB external. Additional external restraints needed. Clear to everybody? Why additional restraints are needed? Because to stop the degree of freedom. Clear to everybody? To stop the degree of freedom, we have to apply more number of restraints. How many number of? M dash minus 1. Means to stop all degree of freedom at here, how many restraints we have to apply? M dash minus 1. M dash value 4 means 4 minus 1 means 3. Here how many restraints we have to apply? 2 minus 1 means 1. So in entire 3 here, 1 here, means total 4 number of external restraints we have to apply. Total 4 number of external restraints we have to apply. Okay, since effect of internal hinge is to provide more number of restraints, therefore its static indeterminacy will be reduced or increased. कम होगी, बढ़ेगी? क्या होगा? Its static indeterminacy will be reduced or decreased? It will be reduced. होगी नहीं? Because number of restraints needed माइनस हो जा रहा है. अभी तक कितना था? नीडेड कितना था? ये यहां पे था ना, -3j. नीडेड वाज ओनली 3j. अब कितना नीडेड? 3j प्लस इफ इट इज r dash. से इट इज r dash. सेम इस केस में बोथ 4 9 वाला नहीं है डिग्री. हाँ वो नहीं है, वो चेंज है. देयर मे बी ए कंफ्यूजन फॉर द कैलकुलेशन ऑफ स्टैटिक इंडेटरमिनेंसी. यू हैव टू टेक ओनली m dash minus 1 or 3 times of m dash minus 1. Okay, in degree of freedom here 4 was there. Okay, but you do not need to take 4. You need to take only m dash minus 1 in both cases. Okay, there should not be any confusion. हाँ, किसके लिए बेटा? वो डिग्री ऑफ फ्रीडम के लिए काइनेमेटिक इंडिटरमिनेंसी में. दैट इज एप्लीकेबल इन काइनेमेटिक इंडिटरमिनेंसी KI में. Okay, but in case of static indeterminacy we have to take only m dash minus 1 or 3 times of m dash minus 1. Clear to everybody? And its effect is to reduce external indeterminacy. Okay, एंड देयरफॉर DSE कितना हो जाएगा? कैपिटल R माइनस स्मॉल r माइनस सम ऑफ R डैश. कैपिटल R माइनस स्मॉल r माइनस सम ऑफ R डैश. Why sum has been applied here? Because दो जगह भी हो सकती है ना, यहां पे और भी हो सकता है. That's why I have applied summation. Get everybody? So this is for internal hinge. Note number 1. Note number 2. For force release. For force release. If so, how many restraints we have to apply for that type of release? What is degree of freedom? What is degree of freedom? Degree of freedom कितना था? Linear, rotational. Therefore, value of R dash. R dash means what? Additional external restraint. Okay? R dash is, value of R dash will be 2. Okay? Here, motion. Which type of motion can be there? Linear only. So, value of R dash will be only 1. Here, only 1. So value of R dash will be only 1. So effects of force release is also same. It also reduces the static external static indeterminacy. Okay? Internal नहीं. Internal में static only external. हाँ. अभी एग्जाम्पल करता हूं, न्यूमेरिकल करता हूं, देन इट विल बी मोर क्लियर. Clear to everybody? So in that case, same expression will be applicable. Same expression will be applicable. Same expression will be applicable. Okay. नीचे लिख लें. Therefore, if a structure has both force release as well as internal hinge, therefore if structure has both force release as well as internal hinge, force release as well as internal hinge, then its effect is only to decrease the external static indeterminacy. Okay, पुलिस स्टॉप करके आगे लिखें, नो चेंज इन किसमें? नो चेंज इन internal static indeterminacy. No change in static indeterminacy. That you have to remember. That you have to remember. Find static indeterminacy. Find internal and external static indeterminacy. Okay. This is what? Joint hinge. Okay, both are joint hinge, no problem. So find out number of joints. Find out number of joints. One, two, three, 4, 5, 6, 7, 9. Number of member. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Restraints, external restraints. Number of support reaction. 3, 2, 2. 3 plus 2 plus small r needed. Restraints needed. 3. Okay. And since internal hinge is there, therefore we have to calculate r dash. We have to calculate summation of r dash. We have to calculate r dash. Here कितना m dash minus 4 minus 1 means 3 here 2 minus 1 equals to, so it is 4 minus 1 plus 2 minus 1 means 3 plus 1 4. Clear to everybody? अब निकाल लो DSE कैपिटल R माइनस स्मॉल r माइनस सम ऑफ r dash. Okay, so capital R 7 minus 3 minus 4. DSA is 0. Okay, DSA is 0 means it is just stable. What it means? It is just stable. If we will provide one more internal hinge, then it will not be able to stable. Okay, clear to everybody? What is the value of DSI? DSI small m 3m plus small r minus 3. Okay, that expression is remain same. Okay, that expression is remain same. Okay, 3 number of member is 10, so 3 into 10 plus small r 3 minus 3 into 9 3 into, so value is 30 plus 3 6. So total static indeterminacy DS 0 plus 6 equals to 6. Clear to everybody? ओके find out the static indeterminacy for that case. Find out static indeterminacy for that case.
हम ये वाले फॉर्मूले से कैलकुलेट करेंगे टोटल को, तो वैल्यू
सेम है
सेम तो नहीं आ रही।
टोटल क्यों
3 into 10 30 plus r 7 minus 0 27
कितना
27 minus 27
एक मिनट देखता हूँ, पहले मैं इसको बता दूं। सो नंबर ऑफ ज्वाइंट्स 1 2 3 ओके, सभी ध्यान दें यहां पे, सभी ध्यान दें, सभी ध्यान दें। देयर इज चेंज number of joint in case of kinematic indeterminacy. We have neglected that this as a joint, but in that case it will be treated as a joint. हाँ, static में that you have to kept in your mind, that you have to remember. हाँ, उसमें आपने काइनेमेटिक बता चुका हूं मैं, काइनेमेटिक इंडिटरमिनेंसी आप इंडिविजुअल ले चुके थे. Okay, it has two different member. चलो, total number of joint here 4. इसको हमेशा याद रखना, भूलना नहीं. Number of joints 4, member 1 2 3. Value of capital R 3 here, 2 here, 2 here. 3 plus 2 plus 2 7. Small r, capital R, sum of r dash, because this is acting. So how much? 2 minus 1. Okay. So DSA how much is that? Capital R minus small r minus ये हुआ 7 minus 3 minus 1 कितना? How much? 3. DSI sigma r dash, number of members connecting to that internal hinge 1 2. Value of m dash is 1. Okay, so m minus 1 ये हाँ 2. So m dash minus 1 value is 2 minus 1. Okay, DSI it is value 0. How much? 3m plus small r minus 3j. 3m, 3 into m is 3 plus r is 3 minus 3j, 3 into 4, so 9 9 plus 3 minus 12 0. ओके, हाँ, नोट करके लिख लें, नोट करके लिखें, बीम ऑलवेज हैज 0 काइनेमेटिक इंडिटरमिनेंसी. बीम ऑलवेज हैज DSI equals to 0. Beam always has DSI equals to 0. Always. It has only external indeterminacy. Clear to everybody? So we will continue in next class. Thank you. So in this question we have calculated the value of static indeterminacy and external and internal static indeterminacy, and we have found that external indeterminacy comes to be 3 using that expression, capital R minus small r minus sum of r dash, and this internal indeterminacy comes to be 0, and value of DSI, it is always 0 in case of beam. That I have told you in last class. Now I would like to tell why this value, DSI value, is 0 always. Now I would like to tell you why this value is 0 always. Clear to everybody? So consider this expression. So considering that DSI equals to 3m plus r minus 3j and equate it as 0. And find the value of members and find the number of members. Means I want to calculate the value of the member forces. I want to calculate the number of member forces needed for just stable condition internally. Minimum number of members for only just internal stability. Okay, so I will get m equals to 1 by 3m 1 by 3j minus r, and it will be j minus r by 3. Okay, for space, since this expression is for plane, therefore it will be j minus 3 by 3 means j minus 1, and this value is the minimum number of members. This is the minimum number of members. That is what j number of joint minus 1. In case of beam, if I have this one 2 joint, and in between 2 joint only one member is possible, and it will always be there. Okay. Just make a table. If j equals to number j and m, make a table. This is the minimum members. For DSI equals to 0. If j is 2, minimum 2 joints can be there. Number of member 1. Joints 3. Number of member 2. Joints 4. 3 member. For 5 joints it is 4. For 6, 5, and so on. Clear? Think of that. If I have 2 members, I have 2 nodes, 1 member will be there always. For further addition of joint, it will need one more member. What is communicating? Addition of one member, addition of one joint, addition of one. Okay, any 4, 5, 3, 4. Okay, further addition of one joint will need 1. Okay, here further one joint, 1 member. And in beam, this type of thing is possible only This type of thing is possible. At the joints, any type of support can be there, no problem. Any type of thing can be there, any type of support can be there. But number of joint and number of member, they will always be in this manner, in this fashion. Number of joint and number of member will always be according to that expression, according to that table. And since that table, कोई भी figure हो, it will give you the value of DSI equals to 0 always. DSI equals to 0. Clear to everybody? Yes. Therefore, in case of beam, there is no need to find the value of DSI because it is the wastage of time. No need to find the value because if you will calculate, then you will find what value? 0. If you are calculating correctly, if you are calculating the correctly, then you will get the 0 value. Okay, so static indeterminacy for in case of beam, it is only external. It is only external, and you know very well external indeterminacy. External. ये अब ऐसा करूं मैं ds in case of beam it is DSE plus DSI. Since DSI is 0 always, so it is DSE. Okay, and in expression form it can be written as capital R, total number of restraints provided, applied, minimum number of restraints required minus R dash, number of restraints needed, further number of restraints needed to make the structure static, So this is the expression. So this is the expression. Now I will solve a few more cases. Suppose I have this beam. Find static indeterminacy for that case. If I have this beam, here what is provided? Force release. Okay, and you know very well such type of force release will have 2 degrees of freedom. Therefore 2 restraints are needed. 2 restraints are needed here. Means value of R dash, it will be 2. Okay. It is for that type of value. Okay. And capital R, you know, the total number of supports 3 here, 3 plus 3 equals to 6. R, small r, since it is plane, always 3. So ds equals to how much? 6 minus 3 minus 2 comes to be 1. Clear to everybody? And value of DSI कोई पूछे? You know very well. अगर पूछ लेता है, then tell that it is 0. पूछता है तो, okay? Clear? Similarly, if I have this arrangement, okay? One more hinge is also provided here. What will be changed? Everything will be same except R dash. In this case, value of R dash will be, it will be 2. 2 तो होगा ही होगा, plus here m dash minus 1 and value of m dash is here 2. That's why it will be 2 minus 1 means 1. So value of R dash will be 2 plus 1 3. And what will be the value of ds? Simply जितना भी था एक और माइनस हो जाएगा 0. Yeah, it will be 6 minus 3 minus 3 comes to be 0. That is right. Means this is the beam which has है ना just stable externally just stable. Okay, if you will provide further hints, then what will happen? Unstable. Okay, it will be unstable. So it is not possible to provide any more number of internal hints. Clear to everybody? Very simple. Now find static indeterminacy for this type of beam. Can you find static indeterminacy for that type of beam? It is link. Can you find? Okay, this is one beam, and both beam are connected with a member, and they are pin jointed type of member. Okay, so you should not worry. You can calculate by same procedure. You can calculate. You know very well static internal indeterminacy will be 0. Internal indeterminacy will be 0 here also. Okay. So calculate the total number of restraints applied. 2 here, 1 here, okay, 1 here, 2 here. So it is 2 plus 1 plus 1 plus 2. It is how much? 6 number of restraints. Okay, and you know smaller value 3. That's very much clear. Sum of R dash. Clear? निकाल ले. Here 2 members are connecting, so the value of R dash here it will be 2 minus 1 means 1. Here R dash value is 2 minus 1 equals to 1. So the value of summation of R dash simply find. Okay, so value of DSE equals to DS equals to DSE equals to 6 minus 3 minus 2 comes to be 1. Comes to be 1. Comes to be 1. Clear? Any doubt? Can you tell me what is degree of freedom? Kinematic indeterminacy. Kinematic indeterminacy. Can you tell me what will be the kinematic indeterminacy for that beam? Kinematic indeterminacy, I have told you, number of joint, degree of freedom per joint into J minus number of restraints minus A plus, okay, plus R dash. Okay, so number of joint. How many number of joint? 1, 2, 3, 4, 5, 6, and member 1, 2, 3, 4, 5 degree of freedom per joint. How much? 3. Because this is a beam and frame always has 3. So put that value. How much? 3 into 6 minus resistance. R is 6 minus plus R dash. R dash is 2. So it is 18 minus 6 plus 2, 14. Okay. So this is kinematic indeterminacy and this is static indeterminacy. कौन सा बेटा? Which one?
जो हिट होता है सर वो हो जाता है सर काइनेमेटिक्स
It is joint. It is joint है ना? It is joint है ना? If this one type of thing is there, इसको नहीं काउंट करना, इसको 4 कर लेना. ओके ये तो ज्वाइंट है ना. 2 members are connecting at a single joint. Clear to everybody? अगर ऐसा है तो कर लेना. इसके लिए फर्दर 4 करना, मत काउंट करना. ओके क्लियर? इसको ज्वाइंट मत काउंट करना. Clear to everybody? और now any doubt? Clear to everybody? Okay, I will tell you one more thing. In case of frame, number of cut methods for DS number of cut method. What is that? Understand. Look here. Now I am going to explain alternative method. Alternative method. Alternative method for DS of. It is very helpful. It is very helpful. In case of frame, we are just counting the number of joints, number of member, and then we are putting the values, putting the suitable values, putting the suitable values. Okay. सभी ध्यान से देखो. If you consider this simple frame, if you consider this simple frame, okay. What is the value of DSE? What is the value of DSI? What is the value of DS? आपको DS is the summation of these two. Okay, we have calculated value of DS as number of joint here. Number of joint here 4. 1, 2, 3, 4. 4 joint. Number of member 3. Capital R. 3 plus 3, 3 plus 3 means 6, small r 3. So DSE, capital R minus small r, sigma r dash is 0 because no internal hinge is there. So it is 6 minus 3 means 3. Value of DSI 3m plus small r minus 3j. And this value 3m, 3 into 3 means 9 plus r means 3 small r 3 minus 3 into j 12, it is 0. So total ds equals to DSE plus DSI, it is 3 plus 0 and it is 0. Clear? that conclusion, that result can be used to find the value of this total static indeterminacy. That result can be used. That result can be used. कैसे यूज करना है ये समझना है. How you can use that result in finding the values of ds, that I want to tell you. That I want to tell you. Okay. The method is provide provide a cut over here. यहां पे आप इसको क्या करें, कट प्रोवाइड करें एंड सेपरेट इट इनटू टू पार्ट्स. सेपरेट इट इनटू टू पार्ट्स. Separate it into two parts. Means this one is individual, this one is individual. Clear to everybody? So this is what? This is cut. And how many places it requires to separate? Number of cut requires to isolate. How many? Here how many supports are there? Only two supports are there, and our intention is to separate all supports. Our intention is to separate all supports, and to separate these supports, how many number of cuts are needed? Only one. Here this one is separated, it is on this one support, and this is, it is also on this one support. So number of cut needed, it is only one. Clear? I am taking another example. Suppose I have this one example. Suppose I have this one example. And tell me number of cuts needed to separate all supports. Number of cuts needed to all supports. How many cuts are needed? Can you tell me? Two cuts? Only two cuts? Think of that. You should all. How many cuts will be needed? 4, 3. Think of that. How many of you agree for 4 number of cuts? How many of you? 4. And 3? Only 1. 2? 3 पे. Okay. Here, देखें. If you have applied a cut over here to separate this one support, minimum number of cut required 1. इसको कट कर दिया. Okay. Okay. ये कट कर दिया. This one is free, but this support is connected by this member. Clear to everybody? That's why you have to also put a cut over here. Therefore, one is here, another is here. दो तो ही हो गया. 2 number of cuts have applied over here. Okay. Now at that time, that support is, this one support is free from other type of structure. Okay. आगे का समझ गया होंगे. कैसे? कैसे? बैठ जाओ. बैठ. यहां से.
ये भी सही है.
हाँ. ओके. It may be the possibility. Okay, no problem. Okay. If you are providing the cut in this manner, okay, very interesting. Okay, then what will happen after providing that cut? That structure will, upper structure will fall down. Your structure should also be stable. Number of cuts needed to separate all support here. But structure, you write one more thing. You write one more thing, and that thing is, structure must be stable. Okay? हाँ, लिख दिया. Structure must be stable. Okay? Okay, no problem. I welcome such type of discussion, no problem. Structure must be so इसको हटाऊं, पॉसिबल नहीं ना? हाँ, अगला ही बोलो. कैसे? करते थे पहले सर, ऐसे से करते सर, दो ही तो लगे वो सर. ऐसे? Okay, so finally we have to apply this. Okay, everyone is stable. This one is also stable. This is so number of cut required. It is 4. बताऊंगा. Now tell me number of cuts needed, but the structure should be in a stable condition. या इसको चलो कोई बात ऐसे ही करो. Number of cuts needed. This one, okay, 2, 3, 3, okay, and this one, 4, 5. Number of cut required. Here, how many supports are there? Only 2 supports. Okay. First of all, you have to think that these supports are hinge support. If they are separated, if they are here, जैसे यहाँ पे, if in spite of this fixed support, if it is hinge, then after providing the cut over that, what will be there? It will tilt down. It may rotate. Okay. So first of all, we have to think for that also. Number of supports. How many supports we have to? How many resistance at the support we have to provide it? So one more thing is number of cut, and another is Say this one is R, number of restraints applied, number of restraints applied at support. Suppose this value is R dash. Suppose this value is R1, not R dash. Suppose this value is R1. And suppose number of cut is C. Suppose this is C and this is number of restraints applied at the supports. To make as fixed. To make as fixed means here number of restraints needed. How many? Only one. Hinge hai. Two restraints are there. One is here 0, 0. Here we need one. Okay, so that it can behave like as a fix. Clear to everybody? Here we have to further provide one more. So total value of R1. Total value of R1, 1 here plus 1 here means 2. Clear to everybody? Now these hinges can be treated as fixed. Clear? That type of thing we have to keep in our mind before applying to cut. Clear? Now how many type of thing can be there? Two number of support, therefore two separate structure can be there. Two separate structure can be there if it has been provided from here. Okay. First one cut can be there, can be this. Okay. Now after having this, you have to free all joints. You have to free all joints. Number of joints are how many? How many? This one joint, this one joint, this one joint. You have to open every joint. You have to open every joint. To open every joint, what you need to do? You need to open this. Means you have to cut here, apply the cut over here, apply cut over here, apply cut over here. And this one is इधर से free है ये, यहाँ से लगाइए. Okay. By providing that. Okay. And this is also free here. Since this is fixed, that's why structure will be in stable condition. So the number of cut required, it will be 1, 2, 3, 4, 5. Okay. Now what will be the total static indeterminacy? That I can conclude. Total indeterminacy using that method can be written as ds equals to 3 times of C minus R1 if it also has internal hinge, then subtract that. This is the value of total static indeterminacy in case of frame. 3 times of C, number of cuts. C represents the number of cut. This one, C represents the number of cut. Value of R1 I have told you. Okay, number of restraints needed at the support only. Okay, this one number of restraints या applied की जगह पे needed कर दे. Number of restraints needed. Okay, number of restraints needed at supports to make fixed. Clear? So
ये स्टेबिलिटी क्राइटेरिया समझ नहीं है सर. इसमें जो स्टेबिलिटी
बेटा ये this is the way, this is the method, this is the alternative, this is the trick.
वो तो सही है सर.
Okay. हमें वैल्यू से ये कैलकुलेट करना है. हमें इसकी वैल्यू हम निकालना है ds. Calculate the value of ds first of all. Okay. Then I will talk to you. Calculate the value of ds for that case. Here, what will be the value of C? Value of C is 4. Number of R1 only 1 for that case. Okay, number 1. And internal hills है summation of R dash, it is 0. Therefore value of DS how many? 4 into 3 minus 1, it has 11. Value of DS has 11. Here value of DS, number of cuts 5. Okay, so 3 into 5 minus 2, 15 minus 2, 13. Okay, now verify these results. Verify these results from the according to the expression whatever I have given to you earlier. Verify that. So tell me the number of joint here. Tell me the number of member here. Capital R, small r, sum of R dash. Number of joint 9. Number of members 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number of members 10. Capital R नहीं, यहाँ पे 2 है ना. 8. 2 plus 3 plus 3 8. R dash 3, small r 3, R dash 0. Okay, so value of DSE, value of DSE, capital R minus small r minus R dash, how much is that? 8 minus 3 minus 0, it is 5. DSI, it is 3m plus r minus 3z. Put that 3 into m. M is 10 plus 3 minus 3 into 9. So it is 30 plus 3 minus 27. How much? 6 is that. So total value of DS 5 plus 6, it is 11. And the same result you have calculated over here. Same result you have calculated here. And that result is much fast. It does not require counting the number of joints, number of members. It does not require the counting of number of joints and number of members. You can calculate very easily. Okay, that is the benefit. That is the benefit of that method. That's why it is alternative. You can verify here also. You can verify here also. But one more thing, that expression gives the total. It gives the total. Clear? It will not give you the internal. It will give the total. Total मिल गया. Calculate the value of DSE. External. Calculation of external indeterminacy. It is not. It is very simple. Only capital R minus small r is simple as compared to counting the number of members and so on. So the capital R, if we know DSE same procedure. 8 minus 3 since it is 5. So find the value of DSI from here. 11 minus 5, 6. So that procedure you can apply. First of all find total, internal, and then find total, then external, then internal. Get everybody? Here you can verify. Tell me the number of joints here. Tell me the number of joints. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. 8 na? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Number of member. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Number of member 11. Capital R only 4. Small r 3. Summation of R dash 0. Okay. So So DSE, value of DSE is capital R, 4 minus 3, it is 1. DSI 3m plus small r minus 3j, put that value, 3 into 11 33 plus 3, okay, minus 3j, j is 24. How much? 36 minus 24, 12. Okay, therefore you can calculate total ds 12 plus 1, that comes to be 13, and it is the same result. You are getting the same result. Okay, you are getting the same result. यहाँ पे so to roller support has only one resistance. Here 2 resistance you have to apply, means 1 here, 2 here. Value of R1 in that case it will be 3. Value of R1 in that case it will be 3. Value of R1 in that case it will be 3. Okay, so if I have this type of frame, can you tell me what is the value of ds? What is the value of ds? It is fixed, it is hence value of ds, tell me. 2. Simple. Number of cut 1, but you need one more. Let everybody. So it will be 3 minus 1, it is 2. Okay, and DSI is clear. First of all you have to calculate DSE. Okay, 3 plus 2 3 plus 2 5, 3 plus 2 minus 3, it is 2. 3 plus 2 minus 2 is the DSE. Okay, so DS value, it is DSI value, it is total DS minus DSE, means it is 2 minus 2. Clear? You can verify it. You can verify it. Okay? After verification you will get the same result. So that is very much helpful. This method is very much helpful to find the static indeterminacy for frame type of thing. Okay? Okay, thank you for that.